High-fat diets don't just fill your arteries, they hollow out your microbiome. Behind the scenes of every greasy burger and creamy dessert, your gut microbes are responding with an increasingly unbalanced shift in their ecosystem. What begins as a subtle microbial adaptation quickly becomes full-blown dysbiosis, a disrupted gut community characterized by reduced diversity, dominance of pro-inflammatory strains, and loss of metabolic functions critical to health. The first domino to fall in this cascade is microbial diversity. A healthy gut thrives on variety, a rich mix of firmicutes, bacteroidetes, actinobacteria, varicomicrobia, and other phyla that maintain balance and resilience. But high-fat diets, especially those rich in saturated fat and low in fiber, select for a narrower range of species. Beneficial bacteria such as Bifidobacterium, Lactobacillus, and Akkermansia often decline, while opportunistic and potentially pathogenic strains like Bilophila wadsworthia, Escherichia coli, and Desulfovibrio begin to flourish. These shifts aren't just cosmetic, they have real functional consequences. The microbial metabolites that normally support immune balance and epithelial integrity begin to change. One of the most striking losses is in the production of short-chain fatty acids, SCFAs, particularly butyrate. SCFAs are generated when microbes ferment dietary fibers, and they serve as the primary fuel for colonocytes, the cells lining your gut. Butyrate, in particular, helps tighten junctions between cells, reduce oxidative stress, and stimulate IL-22 production, which is essential for maintaining the mucosal barrier. In a high-fat, low-fiber environment, SCFA-producing microbes starve, and their numbers shrink. As a result, the epithelial barrier weakens and inflammatory signaling intensifies. At the same time, fat-fueled bacteria begin generating harmful metabolites such as hydrogen sulfide and branched-chain fatty acids, which can irritate and inflame the intestinal lining. Bilophila wadsworthia, for instance, thrives in bile-rich environments, the exact conditions created by frequent high-fat meals, and produces hydrogen sulfide, which can damage mucosal cells and increase gut permeability. This allows bacterial fragments like lipopolysaccharides, LPS, to translocate into the bloodstream, triggering a systemic inflammatory response known as metabolic endotoxemia. Worse yet, high-fat diets seem to reprogram microbial gene expression. Metagenomic analyses show increased expression of genes involved in LPS biosynthesis, toxin production, and oxidative stress pathways in the microbiomes of individuals consuming fat-rich diets. These microbial adaptations effectively turn your gut from a cooperative organ into an inflammatory incubator, a slow-brewing factory for immune disruption. Another casualty of dysbiosis is cross-feeding networks, the intricate microbial relationships where one species breaks down fiber into intermediate compounds that feed others. High-fat diets often starve the system of its core input, fermentable carbohydrates. Without fiber, cooperative microbial metabolism collapses. You're left with fragmented, less efficient microbial functions and an overrepresentation of species that survive not through cooperation, but by feeding on mucus layers or bile acids, activities that further erode the intestinal lining. The resulting dysbiosis becomes self-perpetuating. A thinner mucus layer, reduced IL-22 signaling, and increased gut permeability create an environment that favors inflammation-loving microbes. As beneficial species disappear, immune tolerance is lost. The host immune system begins overreacting to normal microbial products, further damaging the gut barrier and fueling chronic low-grade inflammation, a hallmark of conditions like obesity, metabolic syndrome, IBD, and even neuroinflammation. And here's the most disturbing part. It doesn't take long. Some studies show that microbial shifts can begin within 24 to 72 hours of switching to a high-fat diet. And in individuals with a history of antibiotic use, stress, or pre-existing gut issues, the effects may be even more dramatic and harder to reverse. So when we talk about gut dysbiosis from high-fat diets, we're not just discussing a few missing bacteria, we're talking about a radical ecological shift. The gut becomes less diverse, more inflammatory, and metabolically dysfunctional. Your microbiome, once a complex ecosystem designed to support your health, starts playing for the other team. And unless dietary habits shift to reintroduce fiber, polyphenol, and microbial diversity, the damage only compounds over time. In short, your microbiome remembers what you eat, And when it lives off a steady diet of fat and neglect, it doesn't forget.